All right, this tutorial is about dependent events. What is that? That's when the outcome of one event does affect the outcome of another. It will affect it. Okay, so if we have the probability of event A followed by B, you find the probability of event A and you will take it times the probability of event B after A is performed. All right, so in other words, when it's a dependent event, whatever happens with A affects B in that you are not replacing whatever it is you're drawing or whatever it is you're taking. All right, so how does that work? Well, there is a bowl of 10 fruit chews on a plate. 6 are sweet strawberry, 4 are super sour lemon. You reach in and you eat one. That means that you can't put it back. Okay, so you keep it because you've eaten it. What is the probability of eating a sour followed by another sour? All right, so let's see how that works. Well, we have 10, they tell us that here. There are 4 that are sour, so the first time you reach in, 4 out of the 10 are sour. Well, I've eaten one. That means I no longer have 10 in there. I have 9. We assume that you went ahead and ate the sour, so that also affects the top number. So now I only have 3 out of the 9 that are sour. And then you multiply going straight across. So I get 12 out of 90. And I can divide this out. Okay, so simplifying. So I'm going to go 2 because that's easiest. I get 6 out of 45. I can then divide by 3. So I get 2 out of 15. So if 2 out of 15 tries, you're going to get a sour. Eat it, followed by another sour. All right. Now, how does this work if both of them are not the same? Like if I'm not eating sour after sour. So let's say we do a sour followed with the sweet. It still affects the numbers. Okay. So sour we know is 4 out of 10. I only have 9 left because I ate that sour. However, 6 of the 9 are the sweet. So I can go ahead and cross reduce. Divide by 2 here. Divide by 2. Multiply going straight across. I get 12 out of 45. Divide by 3. So I get 4/15. Okay, so this one, since it's the same thing followed by the same thing here, it affects both top and bottom number because when you eat it, you assume that you grab the sour, but then you're left with 9 left of total in the whole thing, but only 3 of the 4 sours. And then down here, we had sour followed by sweet. That only affects the bottom number because we take that sour, 4 out of 10, we eat it. That means I only have 9 left, but I'm assuming I eat that sour, so I still have all 6 of my sweets. Okay, and then you just multiply going straight across and simplify. Now, how does this work with a deck of cards? So we have a standard deck of cards. It contains 52 cards. There are exactly 4 aces, remember, one of each suit. You draw a card, you do not replace it, and you draw another. So what's the probability of drawing an ace followed by another ace without replacement, meaning I'm not putting it back? So the probability of drawing an ace the first time is 4 out of the 52. Okay, so I'm going to keep it. So that means I only have 51 cards to choose from. And of those, 3 will be aces because I assume I take the ace. And then this one gets messy. You multiply going straight across. Let's see. So we know that's 12. 12's on top. 52 times 51 gives me 2,652. 2,652. And of course, I can simplify that even further. So I'm going to go divide by 2. Okay. And I can divide that by, whoa, you didn't see that, sorry. Divide that by 2 again. So really I'm dividing by 4. So if I divide by 4 top and bottom, I get 3 and 663. 12, 13, 14, 15. I can go one more. I can divide that by 3. Get 221, so I get 1 over 221. Whew. All right. When you're simplifying, don't give up. Keep working at it. Okay. All right. So again, dependent events will affect that second event. You're either going to subtract from both top and bottom, numerator and denominator, or you just subtract from the denominator. Okay. Just pay attention. I hope that helps.